Okay, so in this video, we are going to create our very first shader. I use a tool called VSCode, but this of course will work in any text editor or IDE. Now, if you want to follow along, I do highly recommend you use VSCode because I'm going to be using some plugins that are specific to this tool. And the first of those plugins is something called Shader Languages Support for VSCode. So this plugin is required to enable syntax highlighting and all those good things for GLSL, which is what we're going to use. And you'll also need to install the GLSL canvas, which will use WebGL to display our shader inside VS Code. So once you have those two plugins, let's go into our text editor and create a file called test.frag. Now, you'd expect a GLSL file to have the extension GLSL, but actually fragment shaders have the extension frag and vertex shaders have the extension vert. You can also do GLSL if you want, but most tools are happy with you having the frag and vert extension. I'm going to save this on my desktop. You of course can save it wherever you want. I actually do have some tests already, so I'm going to call this test 3, but you can leave it as test 1 or whatever. Before I start writing any line of code, I'm just going to start off by saying GLSL, or any shader language for that matter, looks a bit weird. I have been writing code for a very long time, and even for me, when I see syntax from GLSL or any shader language, it does look weird. So I'm going to try my best and explain what each line does. Let's go ahead and write this # or hashtag and write if def GL_ES. What this hashtag means is a preprocessor macro, which is something that will be checked before the code compiles. So this is doing an if check to make sure that this file is GL_ES, and that stands for OpenGL Embedded Systems. So that is useful for web and mobile devices, and because we're going to use the GLSL canvas to preview our shader, it will be using WebGL, so you do need this check in place. And what this check is going to do is going to make sure that the precision is medium P. So shaders use floats for precision, and because we're going to be using WebGL, the precision is different for certain things. So let's go into the browser and have a look at this file. So this says OpenGL or GLSL uses high precision for vertex positions, medium for texture coordinates, and low for colors. I think WebGL only supports medium precision. So what this is doing is making all the floats in this shader have a medium precision. So with that done, we can end the if statement. You will notice when we do run the shader, you can actually change this to low P and even high P, and everything will work fine. And I think that's because we don't have any vertex shaders or vertex positions, so it wouldn't actually be using a high P. You'd also notice that you can actually get rid of all this stuff and it will still work. But it's good to put this in place because there are some things that this line is needed for, and without it, the shader won't load, particularly for WebGL, as I mentioned before, because we are using the OpenGL embedded systems. Okay, let's continue. So we are going to create a standard entry point, which is used in most C-based programming languages. GLSL, even though it's its own language, is based off the C and C++ kind of language syntax. So you do have to write a function and then say what type it's going to output. In this case, it will be void. Now let's write GL_frag color. Make sure we are using a capital F and a capital C for this variable, and make sure you have the American spelling of color. Now you're probably wondering, where did this come from? So GL_frag color is a built-in global variable which is going to be used to determine what color each pixel of the shader will be. The type of a frag color is a vec4 type. A vec4 stands for a 4-dimensional vector. By default, vecs are floats, but of course you can have an ivec, which stands for an integer vec, or a boolean vec, so that would be bvec, or a double vec, dvec. But in our case, we are going to stick to a standard vec because that is the type that a frag color expects. And a 4-dimensional vector, like I said before, will have 4 different floats. So in our case, let's just put these numbers in place. So 0.2, 0.3, 0.1, and 1.0. And each one of these stands for a color variable. So this stands for red, blue, green, and opacity. So RBGA. And that is it. That's our first shader built. If you want to see a list of built-in variables that come in GLSL, you can have a look at the Chronos website and look at the specification for all the GL underscore variables. Funnily enough, GL underscore frag color is not included in this documentation because it is meant to be depreciated. But for some reason, we can still use it in this shader and it will work fine. I haven't looked into why, but it just works. So with that done, I'm going to hit Shift Command P on my machine, search for GLSL, and it will bring the canvas option up. I'm going to hit Show GLSL Canvas, and it will render this green color for me. So essentially, what this shader is doing is saying, okay, for each pixel on the page, put this color there. So it's running this program for each pixel on the screen at the same time. So this is cool. This is our first shader, but of course we don't want it to stay here. We want to put it in a game. So in our next video, we are going to focus on putting this shader that we've created, this kind of ugly green color, onto a sprite in our game engine. Thanks for watching. I hope you found this useful. As usual, like and subscribe to this video. And if you don't want to wait till next week to see the following video, check out the link in the description below to see my Udemy course, where all the videos for this shader course are available right now.